Hi, AP Physics students. Here are a few hints about textbook assignment T3.4, page 101, number 12 and 17. Actually, I'm not going to give you any hints about number 12 because it's a little too easy and any hints would make it too easy for you. However, number 17 makes up for this. It has a star, but it kind of almost deserves 2 stars. So that means that I can give you some hints and I think it'll be useful. This hammer throw is a combination of two different things, as you can probably see when you read the problem. It is a projectile motion problem, certainly, but in addition, it is a problem involving centripetal force. And so on this one, the way we'll start this is I am going to advise that you start by imagining an upward velocity. The upward velocity v has two components. It is a vx and a v0y. Now, when you look at this this velocity, unfortunately, we know that this is 41 degrees, but we don't know any of the other information. So that's a little frustrating for you, but you can get tough. One of the things we do know, and this is the secret to the problem, is the distance it travels, x, is going to be vx times t. I will grant that we don't know what t is, and we don't know what vx is, but knowing the angle makes a big difference. So we know that vx is v, whatever that is, times the cosine of 41 degrees, and you multiply that by time. So my suggestion is that since x is 86.75 meters, you could solve this for t being 86.75 divided by v cosine theta, 41 degrees here. So we have this. Now what are we going to do with it? I will give you one more hint in order to get started. What we'd really like is to find the velocity. Well, as this thing goes to the very top of the rise, at the top, the Vy equals 0. That's very crucial because when it lands again, it's twice the time to the top. So at the very top, you have an acceleration, which is negative 9.8, equal to v minus v, so vy minus v0y over time. And notice in this case that at the very top, you have an acceleration of negative 9.8 equals the vy at the top is 0, so you have negative v0y over t. Notice the important thing about this t. This t is not the same as this t. What we could do is the old switcheroo could be useful. Then you would get t equals v0y, which is v sine theta, over 9.8. Then what you could do after that, and we're almost done with what hints I can give you. I could double this time, so I could put a 2 there, and I could put a 2 there. Now notice, this doubled time is the time up and down. It is the same as this time that we found earlier. So what you could do is, certainly to solve them simultaneously, what we're trying to solve for here is the v. Why not take this entire entity and substitute it here for the 2t? That's all I can do to give you a start. Good luck.